Find what we need for today. All right, we were. All right, so yesterday when we were doing this, all right, we started with group 1, right? And I probably drew sodium. And you guys should have this, so you shouldn't have to write it. All right, so we had 11 electrons, right? So I drew sodium. And we said 11 electrons. So we had how many on the first ring?
Is this the reactivity one?
Yep.
Okay.
We're going to summarize it in a minute. I'm just going back and reviewing it. All right. So how many electrons are on the outside ring or the outer shell of sodium? 1. And we said, Nigel, why are you back over there again?
Because I can see there.
No, you just want to be near Grace. Go sit back where you're supposed to be. You can have any other chair you want in the room except near Grace. Yep, you can. All right. So when you look at that Bohr model, okay, we said yesterday every atom wants how many electrons? Every atom's goal is to have what? They want 8 electrons. Okay? So they want 8 electrons. So if they want 8 electrons, every atom has 2 choices. It can either gain or lose electrons in order to get to 8. It's always going to choose to do what's easiest. All right? So if it has 1 on this outer shell, what's easiest for it to get to 8? Okay? It can either gain how many? Can gain 7 more because it has 1. Because 1 plus 7 would equal 8. Or it could lose the 1 electron it has. All right, what's easier, to lose the one it has or to gain 7 more? All right, it's sort of like if I sent y'all to the courtyard during the second lunch, which is going on right now. If I sent you out there with $1, would it be easier for y'all to gain 7 more dollars or to lose the one I gave you? It'd be much easier for you to lose the one I give you than it is to get 7 more out of people, right? No. Not giving away my $1. All right, it's much easier to lose 1 electron, okay, than it is to gain 7 more. So group 1 is going to lose 1 electron. All right, now, then I drew magnesium for you. And magnesium had how many? Had 12 electrons. So we had 2 on the first ring, had 8 on the second ring, and then it had 2 on this outside ring. And if it had 2 on the outside ring, how could it go about getting to that magic number of 8? Well, if it has 2, it could say 2 plus 6, which was gain 6 electrons, or it could do what with the 2 it has? It could lose the 2. What's easier, gaining 6 or losing 2? It's easier to lose 2. Okay, so we said it was going to lose until we got to what number? 4. Okay? When you get to the magic number of 4, all right, and I had silicon up here at that point. Silicon had 2. And then it had 1, 2, 3, 4 electrons. What happened when you had 4 electrons? That's right. It could do either or. It could choose to lose 4, or it could gain 4. Okay? Because we said yesterday we had no way to know which would be easier, right, Diavion? Have fun.
Not even on my phone.
No, you haven't been on your phone at all while I've been teaching. You're going to be struck dead over there. Lord's going to turn you into a crispy critter for lying to me. No, Mario's been on his the whole time. Now, when you get over to sulfur, you better not go to sleep.
You better get off your phone and get on. Leave me alone.
All right, and I think sulfur is the last one we did yesterday. All right, so when we get to sulfur, how many electrons does it have? It has 6, right? So if you have 6 electrons, all right, how can it get 8? If it has 6 electrons, what are the 2 things it can do to get to 8? It can gain 2. That's not what I want to dump thing. It can gain 2, or it can lose all 6. Now, what's easier, to gain 2 or to get rid of all 6 of them? To gain 2. Okay? Now, the last one I was going to draw yesterday that we didn't have time for, not that, was argon. So argon has 2 on the first ring, 8 on the second ring. It has 18 electrons. All right, so how many electrons are on the third ring? Mario, leave it be.
Hey, do what you think. I was in here back the charger that she dropped.
We'll hand it back then. All right, so when you look at argon, if 2 are on the first ring, 8 are on the second ring, and 8 are on that outside ring, what is argon going to do if it has 8 on the outside ring? Nothing. Okay? So argon will not gain or lose. All right? Because it already has 8, it's not going to do anything. All right? Are you with me on that? So we want to talk about the pattern that the periodic table has, and then we want to talk about reactivity. So we got to draw a periodic table. Don't draw it really tiny because I'm going to put stuff in each of the rows. I should say columns. It's always too much for Diavion. She says that to me a lot. Do you say that at sports practice when you go to track, you go to basketball and all that? It's too much. What's your coach say to you?
No, it's not. You can go do it.
Oh, okay. All right, we got it?
I did that because I go. Yeah. I even know. Well, they stopped talking to me.
All right. What?
I get a dumb one, Papa John.
I don't care.
I'm not saying, I'm saying, what do you prefer? You do not get.
Don't get them. I said do not get
I like both of them.
Papa John's is nice. After, if you reheat their pizza, it's almost perfect. Right. Have you ever had a handmade one? It's like this handmade where it's always like comes in medium size. It's like one more.
the ones that come in the black box.
Yeah, those are good. I had the whole thing. I was trying to I left like 2 slices. And
What did you
I
do in the
went
Jordan?
to sleep. And I still had like chicken Alfredo and stuff, because I was like, like,
Oh my God. Jose.
All right. And I'll let you draw.
Why y'all doing that? Jose, y'all are bad. That is.
Because we're going to label all of the groups who loses and gains and who's most and least reactive.
More here with y'all.
If you want to put it on one of the other ones you have, but I don't have those anymore. And I don't know if y'all are big enough, but I don't have one because I delete the notes every day.
So you doing that in the office?
So what?
So you like doing it like.
Everything I have has stuff on it. So
Y'all know she was on.
I already have stuff already on the ones I
Right, what did y'all do?
Besides that, I don't like the ones for this unit, so I usually just
No, funny.
which is why I went back in and put in 6 blank pages. All right, we caught up?
No. So she knows y'all.
Wake over here.
Wake up.
Don't stop talking to you.
Oh, I have stuff. I don't give a draw or not. Alright, so based on what we just said, what is group 1 going to do with its electrons? If I go back to sodium, what is group 1 with sodium going to do with its electron? It's going to lose what? It's going to lose 1. All right, so group 1 will lose 1 electron. Now, if sodium does it, everybody in the group does it. All right? If I go to Mg, all right, what did group 2 with Mg do? They lose 2. Now, I did not draw 13. What do you think is going to happen when we get to group 13? They're going to lose what? Going to lose 3. Very good, now, Jay. All right, when we get to group 14. All right, that was silicon. What did we say was going to happen when we get to silicon? It's going to lose or gain 4. All right, we didn't do 15. We did 16, and we said 16 was going to do what? Gain 2. And group 17 we didn't do. And group 18 we said was going to do what? Will not gain or lose. Whoops. Had that one about 3 years. All right, so we will not gain or lose. Now, these numbers come from the number of outer shell electrons. So we said group 1 had 1 electron. So it was going to lose it, right? Group 2 had, why did I write 3 there? I said 2, bigger than life. I wrote a 2. None of y'all caught that.
I did.
Why don't y'all correct me?
I was just letting you go.
Y'all need to fix that stupid stuff I do. All right, so group 2 has 2 electrons.
It's like you say, you can't fix it.
Well, you need to fix it when I do it. All right, so how many electrons does group 13 have? If we're going to lose 3, how many do they have? How many outer shell electrons does group 13 have? How many does group 14 have? Group 15? Group 16,
6.
group 17, and group 18. All right. Now I want to fill in those 2 blank spots we didn't draw. All right, so what did all of these groups right through here do? Change that color down a little bit. Everybody through here did what with their electrons? They all lost. So metals lose electrons. Okay? Every one of these over here are metals, and they're losing their electrons. Now, when we hit group 14, you guys said they had 4. They'll lose or gain. So what's going to happen when we get to group 15 and they have 5? How are they going to get to 8? We didn't draw a picture of them. And they have 5. How are they going to get to 8? Gain 3. They're going to gain 3 electrons. All right. Same thing in group 17. If they have 7, what do Yavian say to get to 8? They're going to do what? They're going to gain 1. Now, this stuff I wrote in green is going to be incredibly important at the end of the week when we get to naming and bonding. Okay? It's not going away. All right? It's a pattern, though. When we drew this stuff back here, some of y'all are like, I don't get it, Miss Wall. It's okay if you don't get it. You don't have to. You have to memorize the pattern if you're in the I don't get it category. Group 1 will do what? Lose 1. Group 2 will do what? Lose 2. Group 13 will do what? Lose 3. What do we do here? Lose or gain 4. Gain 3. Gain 2. Gain 1. Neither. You're not gaining or losing. Okay? Now, this tells us reactivity. How does it tell us reactivity? All right? Let's go with this. These are the most reactive metals. Okay? They are highly reactive. If they are the most reactive metals, they are highly reactive. They are so reactive you don't find those in nature. Okay? They are only found as compounds. Now, why are they so reactive?
Because.
Yeah, hold on. I changed the size and make it a little better. All right, why are those so reactive? Any ideas? These are only 1 electron away from 8. All they have to do is do what with that electron? Lose it. Okay? They have 1 electron in that outer shell. All right? 1 electron. All they have to do is do what? Lose it. So they are 1 electron away from 8. All they have to do is lose that 1. And suddenly they're at the magic number of 8. So, who else on this periodic table is highly reactive? Which last row? 18 will not lose or gain. They have 8. It's 17. Because it needs to do what also? Gain 1. Okay? So group 17 is the most reactive non-metals. Okay? So they are highly reactive. All right? And again, for the same reason. Because they are 1 electron away from what? 8. These are the ones I call the hose on the periodic table. Group 1 will give it away to anybody who'll take it. All right? Group 17 will take it from anybody who's offered. They're not picking. based on this rationale, who would be the next most reactive groups on the periodic table? If 1 and 17 are the most reactive, who would be the next most reactive? 2 and 16. Okay?
So forth.
Yep. These are, let's say this, moderately reactive. All right, oxygen is a gas we're all familiar with. If you've ever been around anybody who's got an oxygen tank, it says not smoke. All right, will it explode?
No, maybe.
Probably not. However, it might. So they ask you not to smoke around people with an oxygen tank. Okay? But people who are on oxygen do what, y'all?
Smoke.
Smoke. Okay? So that's why I listed as moderately reactive. Okay? Now, if we were in group 1, okay, if we went over here to group 1, which is most reactive, hydrogen is in group 1. What would happen if you were smoking around hydrogen? It would explode. Okay? You'd be a crispy critter if you chose to smoke around your hydrogen gas. Okay? It would not end well for you. But if you're over here in the oxygen family smoking, at least you have a chance of surviving. Okay? Because it's not likely to explode. It might, but it's not likely. All right? Magnesium we often use as a lightweight metal. All right? But I've burned magnesium in here, and I will again in a couple weeks. And I'll show you what happens when you burn magnesium. It makes a really, really white, hot flame. If you've burned sparklers at the 4th of July.
Didn't you do that in here?
I did.
I'll take a picture.
I did. And I will do it again because y'all will do a lab with it probably in a couple weeks.
Can we do
Wait, what?
You will not burn it, I will. If you've done sparklers at the 4th of July, you've burned magnesium. So it's moderately reactive. All right? Now, when you get into here, into the middle sections, all right, into here, these are fairly reactive. They will react, but you don't really have to worry about it. Aluminum foil will react. You put an acid on aluminum foil, it will degrade. But aluminum foil is not something you have to worry about. For example, if you want to put it on your barbecue grill, do you have to worry about it reacting and becoming a problem with the barbecue grill? No. But if you put some hydrochloric acid on it, it's going to react. Okay? So those are fairly reactive. Now, I will tell you, just because we're talking, these are, for the most part, pretty stable. All right? They're a lot like the 13 to 15, but they're not going to ask you about the transition elements. All right. Does everybody have what they need? Because we're going to practice with this.
right now?
Yep, right now. Let me minimize that. Put down the wipes over there.
So,
Yeah.
I guess one.
Okay. Go up a little bit here. All right. So I want us to figure out Group number, the outer shell electrons, the number of electrons lost and gained, and the reactivity. All right. Yeah, because I'm going to call him and he goes aboard. He doesn't know which one I'm going to call him for. All right. So, for reactivity, I want you to use words like we just did a minute ago. Highly, fairly, moderately. Okay? Got it?
No.
Got me some answers. Mario, get out of my chair. Get out of my chair. Yes. You could actually do the assignment, which would be new and different.
Yeah. You know, I could.
Go grab me that attendance sign-in thing in the back. Let's see how much time you've got. Since you're sitting up here at my desk.
I stay here till 4:30 one day.
Yes, dude, you're supposed to sign up.
I stay here first.
What would 18 be?
It's 30 minutes. You done more than that, or is that it? 13 would be fairly.
No, 18.
Not. Mm-hmm. That's one day. You gotta be here for 90 minutes to make up a day. I'm gonna give you 7 minutes for free. Yeah, you made up one day.
90.
It's minute to minute, dude.
Oh,
No.
I can do like Johnson, like tell me to go sit here and call me and go. Even though tell me I was in.
I believe you. He is such a nice guy compared to this one. I'm just not.
You're 2 years away from the title.
I am.
You gotta hold it against my head.
That's just the way it is, dude. Nope, it's not. It's just not. It's just not.
I gotta take 2 days.
So you got to stay 2 days, or an hour and then 30 minutes, or 2 days at 45 minutes. Doesn't matter how you break it up, but 90 minutes is 90 minutes.
So today I stay till 4:30.
If you stay till 4:30, that'll be an hour, and another day at 30 minutes, that'll get you another day. I spell your last name. R-E-S-E-N-D-I-Z. Doesn't matter. I just need to be able to write down you did some work.
That's it.
No, let me just write that in this time.
Oh,
All right, we done? Is that yes or no? No?
You're not done.
We done now? All right, come to the first group there, Andrea. You know me ask a question. Y'all better not tell me you don't know how to do it.
That's me. Okay, big shoe. It's on.
All right, so you got group 2. It's not even group 2. Fluorine.
17.
Boy.
Oh, I was counting it from the. Okay, sorry. Okay, ignore that. Where's the eraser?
You got to make sure you touch the red dot. Did you touch the red one?
I don't. I think I did.
No, that one.
Where? Maybe bigger. Okay. Count it wrong. 17. Actually, 7.
So if you have 7,
So
it'll
you
do
gain
what?
1.
Gain 1.
Reactivity. Well, I just put like, okay.
Will it be highly reactive, moderately reactive, or fairly reactive?
Highly.
So highly.
Oh. That's a lot.
Now we'll go check. All right. How about Malik? Sort of all over cesium, but do it anyway.
That's good.
Go back to group. What group is it in?
Don't make me look. Wait.
Nope, that's the topic number. What group is it in? It's at the top of the column. Look at the top of that column.
Oh. One.
Yes. All right, how about argon? Let me have Jose.
Got it.
What does it say under lost games?
Lose,
What's that word?
lose.
No, go back and put none.
Oh.
Because it won't do anything.
What up, what?
None.
Okay,
Because you said it had no reactivity, so it's not going to lose and gain any.
all right.
All right. Aluminum. Let me have Tyler. Since you're scrolling around.
Where the pen at? Right here?
Yep.
I'm not sure about this one.
All right. What you got?
Is this right?
13-3, lose how many? How many are in the outer shell? How many are in the outer shell?
Oh, 3.
So it's got to lose how many?
3.
Lose 3.
Okay.
All right. And what reactivity would it have?
9.
Somebody help me with the reactivity.
For what?
For which one?
Aluminum.
What?
Fairly. This is why we took notes on this dude. All right, how about chlorine? Let me have Liliana.
Well, can I eat on my food?
In a minute. Stella, you've made up 2 days.
Do I have to say for anything?
I don't know how many you missed.
Like, these feels like.
How many more are you planning to miss also?
Nice. Thank you.
What are you doing?
All right, 17-7 game, Holly. Good. Lithium. Let me have Urelli.
Oh, what? Is that right?
Yes. Last one, nitrogen. How about Elizabeth? Nigel, you're not quite up to 2 days yet.
Do I need to make up time?
How many days you been out?
10?
And yes, you do. You need to finish another day.
Alright,
Particularly if you're still planning on being out again.
yeah, I am.
So you need to time.
Yeah. Are you staying next week?
Yep, it's on the calendar up there on my desk.
Alright, I can stay.
Okay.
Yep. Except gain 5. It's going to gain how many? It's got 5, so how do you get to 8 if it's got 5? Yep. All right, let's talk homework.
Homework?
Homework.
No.
Yes.
Oh. So we got homework?
Yep, we got homework.
No, we don't.
Yeah, we do.
We don't.
Here, hand one out to everybody. Make yourself useful. Now, the paper that Diavion has given you, it's not a crossword.